March 1943. While the Germans still believed that the war was won with discipline, training, and doctrine, an American technician, without rank, without permission, and without a manual, was assembling what would be the most feared weapon in the Pacific, with maintenance tools and destroyed aircraft parts. While the Luftwaffe relied on the accuracy of its bombers and the science of centralized tactics, an American bomber was transformed into a low-altitude gunboat, equipped with 8 frontal machine guns and designed to kill ships 50 feet from the sea. This is the story of how an illegal idea, born outside the corridors of command, would come to completely redesign naval air combat and prove that 20th century warfare would not be won by doctrines alone, but by adaptation, engineering, and creative freedom. Throughout this video, it will be revealed how a single man, ignored by the system, converted the doctrinal failure of the bombers into a weapon of precision and terror, a weapon that would force Japan to abandon its convoys, and that would demonstrate with numbers and destruction what Germany did not want to believe, that the flexible industry and productive insubordination of the Americans would be its true superiority. The war that really mattered was not in the textbooks. She was in the hangars. But before we dive behind the scenes of this forbidden invention, there's one statistic that defines the whole story. In just 40 minutes, a single formation of illegal bombers, armed with 8 front-facing machine guns each, turned 8 Japanese transports and 4 destroyers into smoldering wreckage. 40 minutes. An entire doctrine erased by the brute force of an idea that should not exist. And the most disturbing thing is that this weapon did not come from an industrial line, but from the hands of a lone engineer, working in silence, while the bureaucracy ignored what was about to be born. If you value facts, historical accuracy, and the revelation of these hidden pieces of war, please leave the like and subscribe. This keeps alive the research that keeps history alive. In the second half of 1942, the United States Air Force held firm to the belief inherited from World War I. Bombers flying at high altitudes, dropping bombs in free fall, would be enough to disrupt the enemy's logistics chains. This conviction, taught by generations of instructors and reinforced by European doctrines, would find its collapse in the tropical skies of the South Pacific. The B-17s, the so-called flying fortresses, were sent on missions against Japanese ships resupplying positions in New Guinea. Flying at 5,000 meters high, the bombers dropped their cargo onto moving convoys. The bombs fell with theoretical precision, but the sea, unlike cities, moves. And so are the ships. The actual hit rate recorded was less than 1%, what planners called effective air interdiction, pilots called flying circles for nothing. Meanwhile, Japanese convoys, slow, predictable, and concentrated, crossed the Bismarck Sea with near total safety. They resupplied critical positions, transported thousands of soldiers, kept the front alive. The American pilots, frustrated, watched from above the silent failure of each mission. The Japanese gunners no longer bothered to fire. They knew that the bombs would fall far away. In the Allied High Command, doctrine was not just a strategy, it was a prison. It was unacceptable to many that a high-altitude bomber could be replaced by something lower, more direct, more aggressive. The hierarchical structure of air warfare was still paralyzed in dogmas, but there was an even more paralyzing force, the fear of comparison. Because in the same period on the other side of the world, Germany operated with surgical precision in air blitzkrieg tactics and close tactical control. American officials looked at the German reports with respect and caution, but what they did not admit was that in certain aspects, the Allied doctrinal rigidity was closer to the German line of thought than they imagined. While American factories produced thousands of planes a month, the battlefield revealed the contradiction: numerical superiority without effectiveness, an efficiency that Japan exploited with almost methodical discipline. Within 3 months, Japanese convoys were able to land more than 20,000 additional troops in strategic positions, all passing under the eyes of Allied bombers. This operational failure created fissures in internal reporting. Veteran pilots began to question the doctrine. Field officers repeatedly reported the futility of high-altitude attacks against moving targets. But in Washington, the maps and charts still showed arrows and circles drawn based on perfect calculations, not actual results. In November 1942, a statistic began to circulate discreetly among analysts. For every 100 bombs dropped on ships, less than 1 hit the target, and even these hits rarely resulted in fatal damage. The cost per ton of effective ammunition was absurd, and worse, it fed an illusion of effectiveness that consumed fuel, planes, and lives. Pause for reflection. While the German generals bet on the accuracy of their Stuka bombers in diving, the Americans maintained an attack model that failed in front of each Japanese ship. What makes this comparison even more disturbing is the following data. In 1942, the United States produced 47,000 military aircraft. Germany, in the same period, produced just over 15,000. 3 times as many planes. And yet, the dominant American tactic failed in its primary mission, to disrupt the flow of the enemy. If this statistic surprised you, comment below with, "Logistics wins." The paradox was wide open. The greatest industrial power in modern history was being defeated, not by a shortage of resources but by a shortage of operational imagination. American air power was immense, but its claws were too high to tear apart what needed to be destroyed: the ships. It was in this vacuum of results that the first unofficial ideas began to emerge. Pilots and technicians returning from failed missions began to experiment, adapt, dare, almost always in secret. The maintenance workshops, away from the eyes of the command, became centers of improvised experimentation, not out of ambition, but out of desperation. And among these names, one began to circulate, still in a low voice: Paul Irvin Gunn. A coach turned into a captain. A self-taught engineer with more flight hours in transport than the manuals themselves recognized as valid experience. A man who, in his own way, also watched the Japanese trains go unpunished, and who at that moment was beginning to think about another type of bomber, one closer to the target, faster, more lethal. While strategists in Washington discussed millimeter adjustments in the ballistic calculations of bombs dropped from high altitudes, Gunn watched the sea with a simple question: what if the bomb jumped? This question, seemingly naive but technically daring, would begin a transformation. But before the response, a new tension was emerging in the Pacific. Intelligence reports indicated the formation of a massive Japanese convoy departing from Rabaul, the biggest so far, the ideal target, the last test for a doctrine that had already failed, or the first for something new. In December 1941, as the German war machine paraded over Europe in perfect formation, a retired U.S. Navy technician watched helplessly as Manila fell under the Japanese advance. Paul Irvin Gunn was not a general, nor a strategist. He was 42 years old, with 2 teenage sons, 2 young daughters, and a newly assumed civilian career at the fledgling Philippine Airlines. On the morning that Japanese fighter jets began destroying air defenses in the Philippines, Gunn was on the ground, observing the end of an era and the beginning of his personal war. When General Louis Brereton requisitioned his civilian aircraft for military transport, Gunn did not hesitate. He accepted commissioning as a captain in the Army Air Corps and began flying improvised missions under direct fire. He transported supplies, evacuated wounded, and on one of these missions he was shot down, survived the crash, and returned to the cockpit without question. But no amount of aerial bravery could make up for the growing void. His wife and children were unable to evacuate in time. Imprisoned in Manila, they were captured and sent to the Santo Tomas internment camp. From then on, Gunn didn't fly for orders. He flew for revenge. War, for him, is no longer geopolitical. It became personal. And it was this motivation that transformed him. There was no more room for bureaucracy, regulation, or chain of command. The man who returned to the Australian airstrips was someone different, someone willing to push the boundaries to hasten the end of the war. He had the technical knowledge accumulated in 2 decades as a naval aviation petty officer. He had served in the legendary Top Hatters Squadron and served as an instructor at Naval Air Station Pensacola. I knew where a fuselage could be reinforced, how to redistribute the center of gravity, and how many inches of tolerance a structure could withstand before collapsing under recoil. But he was not a career engineer. He never published an article. He never led a project. He was, above all, an aviation worker. In Australia, he began working with hangars and maintenance crews. But instead of just fixing it, it started to transform. He himself searched downed planes, dismantled parts, tested configurations. He created handmade supports, adapted electrical systems, and calibrated weapons with improvised techniques, all without authorization, everything out of the manual. His superiors considered him a disciplined eccentric, until the results began to show. It was Gunn who first installed 4 front machine guns on an A-20 Havoc bomber. a purely tactical measure, allowing the pilot to suppress anti-aircraft fire before dropping the bombs. The effectiveness was immediate, but the idea remained marginal, outside the official plans. The doctrine still said that bombers should fly high. Gunn's logic, to attack 50 feet from the sea with frontal blasts of 50, was considered suicidal. For him, it was the only possible path. This tension between the technician and the manual would reach its apex in mid-1942, when Gunn began experimenting with B-25 Mitchell bombers. Removing the glass nose and replacing it with a solid aluminum nose, he proceeded to install up to 8 heavy machine guns at the front of the aircraft, all fixed, firing forward. Gunn tested each modification personally. If a gun heated up too much, it created ventilation ducts. If the fuselage suffered from recoil, it was reinforced with internal supports. If weight distribution was compromised, it moved batteries, vests, and radios to the rear section. None of these modifications were included in spreadsheets. None had approval, but they all worked. Meanwhile, the generals continued to set bombing routes to 5,000 feet, where their bombs hit nothing. The irony was increasing. A man without a degree, ignored by the ranks of the command, was creating the most efficient weapon in the air war in the Pacific, without even being able to sign as an engineer. In later interviews, officers would recall how Gunn slept in the workshops, personally tested each system, and refused to release any aircraft until his standard was met. Once, when told that his modification violated Air Force regulations, he replied, "Let me know when the regulations start sinking ships." And indeed, the ships would begin to sink. Soon, the transformation of the B-25 into a frontal attack platform was complete. The harmonization tests, to make all the weapons converge at the same point at 300 meters, were paying off. Pilots began to report successful low attacks, and the Japanese, accustomed to slow and loud bombers, were taken by surprise. But a real test was still needed, an operation that would put not only the aircraft, but the entire philosophy behind it to the test. It would be time to show if one man's fury, channeled in aluminum and gunpowder, could change the course of the war. The warning would arrive in February 1943. A Japanese convoy was forming at Rabaul, the largest ever seen on that front, the ideal target, and General Kenny, newly arrived in the Pacific Theater, needed a miracle. It was then that he heard about Paul Gunn, and instead of punishing him, it gave him a position and an impossible mission. The Japanese command believed that its convoys could cross the Bismarck Sea with destroyer protection and air cover. They bet on speed, discipline, and repetition. What they didn't know was that at that moment, a new type of bomber was already waiting, one that didn't follow manuals, nor orders, nor rules. In the early 1940s, Japan still believed that the war would be decided by the Navy. Their admirals saw aviation as a support, not a decisive force. Since the victory against the Russian fleet at Tsushima in 1905, Japanese doctrine has remained obsessed with classical naval supremacy, battleships, destroyers, coordinated naval formations, and offensive discipline over the open sea. Even after the successful attack on Pearl Harbor, which ironically had been conducted by aircraft carriers, the dominant thinking within the Imperial General Staff was clear: the Navy would win, the planes would only help. This partial reading of modern warfare would soon become its greatest weakness. In 1942, Japanese doctrine treated air raids from the mainland as secondary, almost harmless. A convoy well protected by destroyers and embarked air cover would, in the view of imperial strategists, be immune to any threat from dry land. The concept of continuous air interdiction, fueled by ground-based bombers, was considered logistically infeasible. What the Japanese called a point threat, the Americans were about to turn into systematic annihilation. Meanwhile, in Australia's makeshift workshops and hangars, the Americans operated at a completely different pace. The idea of air raid wasn't limited by geography. It was shaped by necessity. Unlike Japan, which centralized decisions and repressed local initiatives, the Americans encouraged adaptation, and it was precisely this adaptation that would allow medium bombers, until then used for reconnaissance flights or generic bombing, to be converted into ship killers. The irony is brutal. Japan, creator of the most audacious air attack of the war up to that time, still refused to believe that land-based bombers could threaten its convoys at sea. His faith in speed, destroyer anti-aircraft cover, and evasion capability was almost religious. In internal documents of the Imperial Navy, the convoys sent to Leh between February and March 1943 are described as armored against significant air interference. The confidence was such that the formations were kept cohesive, with a fixed navigation pattern and predictable schedules. The Japanese strategic failure was also anchored in self-imposed logistical limitations. Maritime doctrine required that fuel be allocated primarily to the fleet. Land-based aviation, on the other hand, received what was left over, and rarely had autonomy for long coverage or interception missions outside the immediate area of operation. The result? Convoys that traversed vast areas of the Pacific without any long-range air cover, only with the doctrinal faith that they were secure on principle. And it was this principle that began to crumble, quietly, with the first low-level attacks by American bombers. The tactical impact was immediate. Front-facing machine guns swept the decks before the Japanese gunners could respond. Bombs jumped over the water, hitting ships at mid-height, at their most vulnerable points. The destroyers designed to hunt for submarines became easy targets for a type of attack that Japanese doctrine simply did not anticipate. This misreading had deep roots. Japanese military culture was based on absolute hierarchy, honor, and technical rigidity, while the Americans allowed sergeants and captains to modify planes, test tactics, and write field reports with real influence on doctrine. The Japanese cracked down on any initiative outside the formal chain. The result was a fatal delay in response. Instead of adapting their convoys, diversifying formations, or revising their tactics, the Japanese persisted in the model that had worked up to that point. And like any doctrine that does not evolve, they were overcome. In Germany, military observers were watching with concern the growing losses of the Japanese Navy. An internal Luftwaffe memo, dated July 1943, analyzed the impact of the low-level attacks in the Pacific. The note noted that Japanese doctrine failed to anticipate the use of front-armed medium bombers as maritime interdiction platforms. The analysis ends with a sentence that, at the time, sounded almost like a warning. The sea is no longer the exclusive domain of the surface. The most direct confession would come years later, from a Japanese officer surviving the Battle of the Bismarck Sea. In an interview with the Yomiuri Shimbun newspaper, he stated, "We didn't know what hit us. They flew too low for us to detect, too fast for us to react, and they shot before we saw their faces. But by the time Raoul's convoy left for Leh, none of these warnings had been heeded. The Japanese command relied on numbers, tradition, and luck. What they didn't know was that ahead of their route, modified bombers were waiting, not to observe, but to destroy, and that this destruction would begin not with bombs, but with direct fire from 850 machine guns. In the stuffy hangar of Townsville in northern Australia, an anomaly was quietly born. It did not follow Pentagon plans, nor guidelines from Douglas or North American. It was a creature assembled with leftovers from war, empirical guidance, and accumulated anger. Paul Gunn, with his team of mechanics and technicians, had received the first B-25 Mitchells damaged in combat. The aircraft was robust, reliable, but ineffective against ships. It was too slow to maneuver like a fighter and, until then, too weak to engage protected targets. Gunn decided to ignore this. He began by removing the glazed nose, designed for navigation and bombing, and replacing it with a block of reinforced aluminum. There he installed 4 fixed 50 machine guns, then 2 more, and finally 2 more on the sides. The B-25 now had 8 heavy cannons pointing forward, all fired by the pilot. Each burst breathed fire with the power of an anti-aircraft battery. The impact was brutal. The recoil threatened the fuselage structure. The heat melted wiring. The center of gravity changed with each new piece of equipment. But Gunn solved everything with artisanal precision. He created internal reinforcements, redesigned the electrical system, adapted supports with handmade welds. It was trench engineering, far from the drawing boards, and closer to instinct than calculation. Tests proved that it worked. The aircraft didn't just fly, now it hunted. In low flight, the new B-25 tore through ship formations like a razor on paper. The irony of this story is that the solution had always been in front of them. While the Air Command in Washington fine-tuned theories of precision bombing, the practical answer came from an isolated hangar in the Pacific, where urgency and improvisation replaced planning. If you're enjoying unraveling these forgotten facts of the war, show your support. Like and subscribe so we can continue to bring you content with this level of detail and truth. The crew of the Frankenstein, as the mechanics came to call the plane, noticed an immediate change in operations. Pilots reported attacks that lasted seconds. They fired before the Japanese defenses could react, cutting bridges, silencing machine guns, and clearing the way for bombs that bounced over the water until they exploded in the hull. Most impressively, even with all this firepower, the B-25 could still carry bombs, light torpedoes, or additional fuel tanks. It was the birth of a hybrid category, which no manual foresaw. Meanwhile, in Europe, the Germans still relied on separation of duties. Fighters for air combat, bombers for destruction of fixed targets, land-based gunboats for infantry support. The idea of mixing all these capabilities into a single platform was seen as technical heresy. But the Americans, by necessity, urgency, and the freedom their industry allowed, were unwittingly creating the future of attack aviation. Local success led to an impromptu serial production. Gun standardized the modification. Each new B-25 that arrived was disassembled, reinforced, armed, and tested before being delivered to the front line. And it didn't take long for the drivers to ask for more. More weapons, more shielding, more aggressiveness. The doctrine began to crumble under the weight of practical results. And the senior officers, once skeptical, now visited the hangars to understand how this unauthorized creature had become a favorite of the pilots. An internal report of the 5th Air Command, dated March 1943, carried the phrase that would change the fate of the weapon. The results obtained by this unconventional variant surpass all available standardized models. It was the first official recognition of the effectiveness of the modified B-25. From then on, what was previously tolerated began to be encouraged. Production accelerated, but the Japanese still didn't know what awaited them. They continued to sail in formation, confident in the destroyer's capabilities, ignoring attack reports coming from the south. In the American command, General Kenny watched the preparations for the attack that would be decisive, and as the Frankenstein bombers lined up their engines, a new doctrine was about to be born, a doctrine written not by theorists, but by pilots, technicians, and engineers who had decided to stop making mistakes and start destroying. What would come next would not only be a tactical victory, it would be living proof that in modern war, accurate improvisation is worth more than perfect theory. And in the Bismarck Sea, that truth would turn to fire. In the summer of 1942, the American military hierarchy was still steeped in a bureaucratic mindset. Every modification had to be approved by departments in Washington. Every technical decision went through committees, and every out-of-scope innovation was seen as a disciplinary violation. Within that system, Paul Gunn was a moving bug, a technician with no real rank, performing illegal modifications to bombers with improvised parts. At another time, he would have been removed, perhaps even arrested for violating technical guidelines of the Air Corps. But then the unexpected happened. General George Churchill Kenny landed in the Pacific. Appointed commander of the 5th Air Force by MacArthur himself, Kenny was known for a rare trait among the military's top brass. He listened. When reports reached him of a mad engineer who had turned a medium bomber into a flying gunboat, Kenny did not order an investigation. He asked for a demonstration flight. Within a few weeks, Kenny understood what he had in his hands, a weapon that the manuals did not recognize, but that the results confirmed. Field reports showed that gun-modified bombers were achieving hit rates up to 12 times higher than conventional operations. Kenny didn't just approve the use of the aircraft, he promoted Gunn officially to technical responsible for the adaptation of the B-25s in the South Pacific. For the first time, the creative freedom of a technician merged with the institutional power of a general. It was the spark that was missing. Kenny's support secured something no other officer had granted: resources, spare parts, access to damaged aircraft, priority in maintenance workshops, and above all, autonomy. Production of the modified B-25s jumped from 3 units to more than 30 in 2 months. Mechanics now had dedicated tools. The modifications began to follow a semi-official pattern, with technical documentation made by Gunn's own team. An unauthorized manual began circulating among the squadrons, teaching how to convert a standard B-25 to a front version. Meanwhile, on the other side of the world, the Luftwaffe ignored any doctrine that had not been conceived within the OKL. Subordinate engineers could not alter approved designs without an extensive chain of permissions. Attempts at adaptation in the field, such as conversions from fighters to fighter bombers, were tolerated only as an emergency, never as a doctrine. The irony was cruel. The country that prided itself most on its engineering was paralyzed by its own rigidity. The United States, accused of soulless industrialism by its enemies, was winning by the ability to improvise en masse. In Townsville, each hangar was transformed into a makeshift assembly line. Gunn personally supervised each aircraft before the flight. The pilots received direct instructions from whoever had created the modification, and more than that, they gave a return. The doctrine was now alive. With each mission, combat reports were analyzed and transformed into adjustments. In less than 2 months, the front version of the B-25 underwent 4 structural upgrades. Kenny saw, with clinical eyes, what was happening. I knew there was something new there. And more importantly, he understood that in order to win in the Pacific, he would need to break with tradition. He ordered all B-25 units in his jurisdiction to undergo technical evaluation with Gunn's staff. What started as an exception has become a new standard. Pilots, once hesitant, now lined up to fly the gunships, the informal name they began to use. The general also knew how to sell his vision. Reports sent to Washington omitted the term unauthorized modification and emphasized operational improvement based on field data. Kenny spoke the language of bureaucrats, but he acted with the courage of hangar men, and this rare combination made a difference. For the first time, the U.S. Air Force in the Pacific was not just reacting, it was reinventing itself. In the Philippines, where Gunn's family was still held prisoner, the news never arrived, but in every plane he delivered there was a trace of quiet urgency. It wasn't just war, it was personal, and this human trait contaminated the entire operation. The pilots knew who had assembled the plane they were flying, and they knew that this technician slept next to the fuselages because he didn't entrust the project to anyone else. In February 1943, the warning arrived. A Japanese convoy had left Rabaul bound for Leh, carrying more than 6,000 troops and strategic supplies. It was the largest naval movement since Guadalcanal. The operation to intercept this convoy was still being planned, but Kenny already knew what weapon he would use. The B-25 gunships would be on the front lines. Behind the scenes in the Luftwaffe, an intelligence report indicated that the Americans were testing a new approach to air interdiction, but German officials did not believe that a medium bomber could take on direct offensive duties against ships. On the battlefield, doubt would be costly. Reality was about to be rewritten, and in the Bismarck Sea this rewrite would begin with 8 machine guns firing less than 50 feet from the surface. In Townsville, Australia, the concept of the factory disappeared. There was no production line with belts, no defined schedules, and no technical organizational chart. There were hangars of beaten ground, damaged planes, exhausted mechanics, and a clock that ran faster than the command. It was there, under the brutal urgency of war, and without a single approved official plan, that Paul Gunn built the first invisible assembly line in the history of modern aviation. Every B-25 bomber that arrived was a promise of power, but also an engineering problem. The recoil of the 850 machine guns installed in front of the aircraft caused microfractures in the fuselage. Gunn responded by internally reinforcing the structure with rods repurposed from damaged landing gears. The overheating of the front pipes threatened to fuse the electrical systems. He inserted ventilation by manual channeling, made with repurposed exhaust pipes. The center of gravity, altered by the frontal weight, unbalanced the flight. It redistributed the batteries to the tail and removed secondary armor. None of these solutions were in manuals, but they all worked. With the support of General Kenny, Gunn received authorization to assemble a task force of technicians. Within weeks, the 5-man team had grown to 40. They were not elite engineers. They were sergeants, mechanics, and operators who learned by repairing. With each new plane, the problems repeated themselves, but the solution was faster. They created handmade templates for installing the machine guns, aluminum molds for reinforcing the solid nose, and a handwritten checklist system affixed to the walls with tape. No formal document came out of there, but the planes flew, and they killed. The process was crude but effective. A standard B-25 took 96 hours to be converted into a gunship. The team operated in 18-hour shifts, sleeping on mattresses next to the aircraft. When the parts were missing, they dismantled scrap metal. When the tools broke, they forged new ones. The philosophy was simple: Every minute lost was a Japanese ship delivered intact to the front line. Meanwhile, on the other side of the world, the Germans kept their production centralized, rigid, and precise. A new model was only approved after months of testing, reviews, audits, and approval by the High Command. Messerschmitt, Junkers, Heinkel, all operated within the confines of formal engineering. The results were sophisticated aircraft, but slow to adapt. An engineer couldn't touch a fighter jet's design without passing through Berlin. In the Pacific, a sergeant with pliers could redraw an entire doctrine in an afternoon. The contrast was more than technical, it was philosophical. American industry, often underestimated as bulky and noisy by Axis officials, showed its true strength, adaptability. It wasn't just a matter of producing more, it was to produce differently, faster, and with real feedback from the battlefield. In Townsville, Gunn mounted his reverse engineering in reverse. He did not start from an ideal design, but from a failure in combat. Each gunship was born from the previous defeat. The result was an unprecedented plane. It fired with more power than any Japanese fighter. It flew lower than any conventional bomber. It could destroy a destroyer with a single frontal blast and still carry bombs for completion. It was both a weapon of attack and deterrence, and its production did not depend on the factory. It depended on ingenuity. By February 1943, the makeshift assembly line had delivered 47 modified aircraft. Of these, 39 were tested in real combat with a survival rate above 90%. Pilots now vied for the right to fly a gunship. Reports recorded terms such as aerial predator, convoy hunter, and suicide aircraft that survives. Morale was rising, and with it, the weapon's reputation grew beyond the Pacific. An internal German intelligence memo, intercepted months later, showed bewilderment. Reports indicate that the Americans are operating medium bombers in an offensive role of frontal naval attack, with devastating results. The technical characteristics are incompatible with officially recognized models. German engineers simply couldn't believe that a bomber was capable of performing what the gunships did. The conclusion was inescapable. The war was being won not just by tanks, ships, or planes, but by the ability to break rules when they failed. And in the Pacific, every bolt tightened outside the manual meant one less Japanese ship on the beaches of New Guinea. The clock was now ticking toward the inevitable confrontation. The Japanese convoy had left Rabaul with 16 ships. Among them, 6 troop transports, 3 armed cargo ships, and 7 escort destroyers. The gunships were ready, the pumps were adjusted, and the machine guns calibrated to converge 250 meters away. Japanese doctrine did not yet know, but it was about to be wiped off the map by planes assembled from scrap metal parts. Amid the humid heat of northern Australia, the doctrine of naval warfare was being rewritten by 2 men not allowed to indoctrinate: Paul Gunn, the improvisational engineer, and Meiji Edlana, a flight officer with a background in offensive tactics, combined field knowledge and pent-up anger to redesign the way planes attacked ships. The idea was absurd at first glance. Low 50 feet from the sea, with jump bombardment. The technique, inspired by British operations against dams, consisted of purposely dropping bombs so that they bounced over the water like stones, hitting the side of ships below the waterline. But there, adapted to the jungle of the Pacific, the tactic took on a new meaning. The planes didn't just drop bombs, they strafed the deck at 300 km/h seconds before impact. The sequence was devastating. Machine guns destroyed the command and silenced the artillerymen. Low-flying bombs pierced the hull. And it all happened in less than 10 seconds. The effectiveness was not theoretical. It was statistics. In simulations, 3 B-25s modified with this doctrine had the potential to sink a destroyer in a single coordinated pass. No Japanese fighter could intercept in the necessary time. No maritime evasive maneuver worked. American doctrine, for the first time, did not react to the enemy. It shaped the battlefield. This tactic, created without a manual, without authorization, without indoctrinators, turned each plane into an aluminum razor. Meanwhile, the Germans maintained their confidence in the separation of duties and the very high accuracy of the vertical bombardment carried out by Heinkel and Dornier squadrons. Attacks on ships were still made at medium height, with optical sighting and ballistic calculation. The concept of a frontal attack at low altitude was seen as suicide. But in the Pacific, this suicide sank vessels every week. And here's a statistic that Axis strategists never included in their calculations. By 1944, the United States would have produced 300,000 Browning 50 machine guns, compared to only 34,000 MG 131s by the Luftwaffe, a number that not only reveals volume, but doctrine, a doctrine where machine guns were not supporting pieces, but the backbone of the air offensive. If this difference surprises you, comment below. Absolute power. With the support of General Kenny, the jump doctrine was taught to dozens of pilots in record time. There was no gym, no classroom. The training was done in the air, with simulations on flooded areas and real tests with decommissioned ships. The margin of error was reduced to meters, the execution, seconds, and the pilot's morale increased with each successful mission. The new doctrine spread like wildfire. Field reports were compiled and turned into makeshift manuals, mimeographed, distributed among squads, and translated into direct language. No tactics by analogy or staggered attack theory. The orders were simple: fly low, aim at the deck, fire first, drop bomb on the jump, and don't look back. In less than 2 months, the tactic had become standard in B-25 units in the Pacific. While Japan reinforced destroyers with cannons and sensors, the Americans bet on speed, improvisation, and brutal repetition. Instead of flying higher to escape anti-aircraft fire, they flew lower to avoid it altogether. Instead of attacking in programmed waves, they attacked in coordinated swarms. It was riskier, but much more lethal, and it worked. The change was so radical that even Washington strategists were slow to accept it, but the numbers didn't lie. In operations against coastal convoys, gunships modified with jump doctrine had a 600% higher destruction rate than conventional missions. The countryside once again taught theory. On the other side of the globe, a Luftwaffe officer captured in 1945 revealed in interrogation, "We knew that the Americans had industrial strength, but we didn't know they had that freedom. It was their freedom that destroyed our tactics." In the Pacific, this freedom would gain its ultimate test. The Japanese convoy that set sail from Rabaul was carrying more than 6,900 troops, supplies, and vehicles to reinforce Leh. It was protected by 7 destroyers and escorted by 0 planes from Kavieng Air Force. The route was mapped out. Japanese doctrine relied on their speed, cover, and coordination, but he ignored one factor. Planes now descended from the sky armed by engineers without a patent and guided by manuals that no one had written. At dawn on March 2, 1943, the Pacific sky was clear. The Japanese operation to reinforce Leh was proceeding confidently. The convoy had left Rabaul in classic formation, 8 armed transports carrying more than 6,900 troops and supplies, escorted by 4 destroyers and protected from a distance by 0 fighters from the Kavieng base. The Japanese Admiralty considered the operation safe. The route had been studied to avoid the main American lines. The average speed was 7 knots and communications indicated calm seas. No air threat would be detected before dawn. That was what they believed. At 09:00 a.m., from the southern horizon, the first ones came. Low-level formations of B-25 gunships loomed like shadows over the waves. No warning, no dispersal maneuver, no time to counterattack. The front machine guns opened fire less than 300 yards from the first ship. The volleys tore through the deck and the command gangway before the gunners could reach their positions. Within seconds, the planes dropped jump bombs that ricocheted over the sea and hit the flank of 3 freighters almost simultaneously. Chaos ensued. The Japanese command system, dependent on centralized orders, collapsed as the vanguard ships began to explode. The destroyers tried to react, but they were surrounded. The second wave of B-25s arrived minutes later, in an oblique line. The attack was coordinated with millimeter precision, a frontal burst to neutralize the defenses, followed by timed bombs that penetrated below the waterline. 1 destroyer sank in one piece in less than 4 minutes. American pilots would later report that there was no battle, only execution. In all, 105 bombs and more than 12,050 cartridges were dropped. The result was absolute. 8 transports sunk, 4 destroyers destroyed, 3,000 soldiers killed in action, and another 2,700 drowned or missing. Within 45 minutes, the Japanese naval security doctrine evaporated. The Zero fighters, delayed by coordination error and limited range, arrived when the sea was already ablaze. They found no targets in the sky. The gunships were already returning to base to rearm, and they would come back. The next day, the attacks continued, with even greater precision. Reconnaissance planes painted surviving targets for further raids, and the Imperial Navy, proud and unyielding, suffered its greatest logistical defeat up to that point in the war. The Japanese reports were laconic. No vessel completed the mission. Total losses. The psychological impact was devastating. From that time on, Japan avoided using large convoys during the day in areas within range of land-based bombers. The war had changed, and the weapon of change had not come from a large factory but from a makeshift hangar. On the American side, General Kenny summed up the battle with operational coolness. "We apply doctrine. It worked." But in the hangars of Townsville, among pieces of aluminum and motor oil, Paul Gunn knew what it represented. Its modification, illegal, improvised, rejected by theorists, had just become the greatest ship killer in the Pacific. In Berlin, a report by Kriegsmarine Intelligence recorded, the Americans used attack aircraft with an unidentified pattern. Result, total annihilation of the target. The conventional bombing doctrine does not explain such losses. At the bottom of the document, a handwritten note from a German officer read, "If this is true, the sea is lost." But this was only the surface of the revolution, because what was to come was not just adaptation, it was multiplication. And the next step would no longer be improvised, it would be production on a large scale. On the morning of March 4, 1943, as smoke still rose over the Bismarck Sea, the telegraphs of the Japanese Naval High Command carried the most feared message since the beginning of the war. Convoy lost, almost no survival, doctrine failed. The defeat was not just tactical, it was doctrinaire. For the first time, Japan was witnessing the complete collapse of its model of naval warfare, one that for decades had been built on the supremacy of battleships, the protection of destroyers, and faith in the invulnerability of coastal logistics. The psychological impact was immediate. Internal reports from the Imperial Navy reveal an abrupt change in tone. References to Japanese naval supremacy have disappeared, replaced by warning phrases such as air uncertainty and logistical fragility in zones under enemy range. What the Battle of the Bismarck Sea had demonstrated with brutal clarity was that maritime security, as Japan conceived it, no longer existed. Naval supremacy had become irrelevant in the face of a new threat, a threat that came not from the bottom of the sea or the horizon, but from the sky, and not predictably. The American offensive did not fit standards. It appeared where it should not, with weapons that were not in the manuals, using doctrines that did not even have a name. The fear spread quickly. Troops stationed at Leh refused shipments by sea. Senior officials have suggested changing the entire Solomon Island supply chain to alternative methods, such as planes and submarines, even if less efficient. A Japanese Admiralty report, dated March 6, stated, "It is unlikely that convoys can be used in areas where the enemy possesses air bases with medium bombers armed in an unknown manner." The term, unknown form, would be repeated 7 times throughout the document. The shock went beyond material loss. The Japanese were not prepared to face what they did not understand. Naval doctrine was based on predictable orders, rigid structure, and known tactics. The gunships violated this logic. They attacked outside the standards. They combined frontal bursts with jump bombardment. They acted in unpredictable lows, often at night, sometimes with the support of fighters, sometimes alone. The Japanese logic of tactical escalation and chain reaction collapsed in the face of a force that simply did not play the same game. In psychological terms, the trains came to represent a death sentence. What was once a transport mission protected by naval honor was now seen as an unacceptable risk. This undermined Japan's ability to sustain land campaigns in places such as Papua New Guinea, Guadalcanal, and eventually the Philippines. Fuel, ammunition, and reinforcements simply did not arrive safely anymore. And here, technical irony reaches its cruelest form. The Imperial Navy, considered by many to be the most disciplined and experienced in Asia, was destabilized by a modified airplane in makeshift hangars, created by a technician with no official rank, and who had never designed a fighter, torpedo, or bomber before the war. The weapon that was not included in the intelligence reports now dictated the geographical limits of the Japanese advance. On the American side, the victory was absorbed with a mixture of enthusiasm and surprise. Harm was expected, not annihilation. Resistance was expected, not collapse. General Kenny ordered accelerated reproduction of Gunn's pattern to other fronts. Entire units of B-25s were converted to gunships. Paul Gunn himself was promoted to tactical consultant in the field, participating in mission planning based on the type of modification implemented. It was the culmination of a cycle that had begun outside the formal orders. In Germany, Luftwaffe intelligence viewed the event with skepticism. A report dated April 1943 stated, "American success is probably due to the vulnerability of the Eastern enemy. It is not proof of technical superiority. The approach is risky and without formal precedent." The refusal to recognize the innovation was as symptomatic as the Japanese defeat. But for Americans, the message was clear. It worked, and it could be expanded, not by miracle, but by a factor that the opponents still did not fully understand: freedom. Freedom to modify, test, make mistakes, try again, and finally win. The next step would be even bigger, because now what was once improvisation would become official doctrine, and from Gunn's improvised line would be born standardized versions of an aerial assassin who would change the course of the conflict and redefine the role of tactical aviation in the 20th century. The American reaction to the victory in the Bismarck Sea was not celebration. It was reorganization. In less than 2 weeks, representatives of North American aviation arrived in Townsville to take a close look at what Gunn had done in the makeshift hangars. What they found was not a formal design, nor elaborate technical diagrams, but a set of practical and empirically proven solutions that transformed the B-25 into a hybrid weapon. To the American aircraft industry, that was raw gold, real results, obtained without months of bureaucratic testing, proving that aviation could kill ships as efficiently as a submarine. The decision was immediate. North American overhauled part of its production lines in Kansas City and Inglewood to incorporate the solid nose with front machine guns, internal reinforcements, and low-altitude strike capabilities. Improvisation became official engineering. What was once considered a regulation violation was now a factory guideline. The speed of the transition reflected America's most powerful engine during the war, an industry capable of absorbing outside ideas and turning them into production at scale. While in Germany, each modification required hierarchical approval, technical audit, and adaptation time, in the United States, a report of proven combat effectiveness was enough to trigger a new assembly line. By 1943, American factories functioned like living organisms, absorbing innovation from the field and returning new, improved versions to the field. The B-25G came about like this, with a 75mm cannon and 4 factory-integrated front machine guns. The B-25H went even further, adding more armor, 8 machine guns in the nose, and standardized weight redistribution. None of these models required years of planning. All it took was a single concept: Gunn to prove that it worked. Industrial engineers have only formalized instinct. American strength was in contrast. While German engineers obsessively protected the integrity of their original designs, correcting small flaws in long test cycles, the Americans looked for flaws to convert them into new weapons. There was no aesthetic pride in the machine. There was pragmatism. The industrial philosophy was simple. If the enemy adapted slowly, the advantage was not only in quantity, but in the speed of transformation. This logic allowed the United States to produce, in 1943, more aircraft than Germany and Japan combined, and for 3 completely different variants of the B-25 to be incorporated in less than 10 months. Internal competition also accelerated the process. Unlike the rigid German corporate structure, American companies competed for contracts, seeking to deliver faster, cheaper, and with better results in combat. Gunn's innovation turned into a silent industrial race. Factories competed for improvements, proposing alternative armament arrangements, new internal reinforcements, modified cooling systems. Ideas flowed top-down, bottom-up, and laterally between companies, in an ecosystem that transformed individual creativity into state capacity. What Gunn had done out of desperation, the factories replicated for efficiency. What was improvisation became standard. What was a risk has become doctrine. Germany watched all this with bewilderment. In internal Luftwaffe reports, officials stated that the Americans seemed willing to destroy their own bombers to test engineering hypotheses. They did not understand that this calculated risk was the essence of American advantage. Mass production allowed one to fail without losing the war. Decentralization made it possible to test without waiting for a ministerial signature. The industrial culture made it possible to transform an isolated idea into a strategic tool. Now, with the new variants in production, the Pacific would see something even more dangerous than gun improvising in a hangar. It would see entire factories replicating his technical courage on a continental scale. And when these new models reached the front, Japan would no longer face an improvised weapon. It would face an entire industrial policy aimed at destroying its convoys. The next step in that process would reveal something even more radical: the conversion of the B-25 into a flying cannon that would turn destroyers into scrap metal before their radars even detected the attack. When the first reports of gunship attacks reached Berlin, the Luftwaffe High Command hesitated. The performance of the modified B-25s was described as unusual, erratic, and ultimately, potentially effective. The reaction was not of technical interest, but of doctrinal skepticism. In the German mindset of the time, the low-altitude frontal assault with heavy machine guns was seen as an inferior tactic, a violation of the principle of aerial precision that the Luftwaffe had cultivated since the 1930s. The German engineering elite, trained under a culture of perfection and structural excellence, refused to consider that the American Air Force was winning with primitive solutions. The German obsession was different: optimal performance, refined machines, results modeled in the laboratory. While the Americans shaped their doctrines with oil, noise, and actual tests, the Germans were still searching for the perfect aircraft, one that never came in time. There were isolated attempts to respond. Some engineers from Focke-Wulf and Messerschmitt suggested modified versions of the Ju-88 and Me-410 for frontal impact attacks, with multiple cannons in the nose. But the proposals were stuck in bureaucracy. They required simultaneous approval from three bodies: the Air Ministry, the SS Armaments Directorate, and the Luftwaffe's Tactical Doctrine Office. None of them agreed with changes that did not go through years of testing. German rigidity, in times of total war, proved to be its own saboteur. The doctrine was static, and the engineers, as talented as they were prisoners of the system. The contrast with the United States became stark. While Germany insisted on centralized, time-consuming solutions, the Americans were already operating hundreds of B-25H with 75mm cannons, a weapon originally designed for tanks, mounted on planes cruising the Pacific at 370 km/h. American doctrine didn't just accept the risk, it rewarded it. And here, a precise statistic exposes the abyss. By 1944, the Luftwaffe had produced fewer than 300 attack aircraft adapted for frontal missions. In the same period, the U.S. produced more than 4,300 B-25s modified with frontal machine gun or large-caliber cannon configurations. This represents more than 14 times the tactical conversion capacity. If this number surprises you, comment below. Shocking data. The root of the German problem was not a lack of technical capacity. It was a closed decision culture. The system valued ideas that passed through hierarchies, that obeyed multi-year plans, that sought the ideal machine. Albert Speer himself, the Minister of Armaments, wrote in his memoirs, "We had the right engineers, but the enemy had the right system." This phrase defines Germany's strategic tragedy. The brains were there, but the ideas could not escape the institutional labyrinth. Meanwhile, the United States made decisions in days, not quarters. A combat unit reported a result. Days later, a modification was tested on the ground. Weeks later, it went into limited production. The innovation chain was functional because industry was not an extension of the government. It was a tactical partner in the war. In an attempt to make up for this gap, the Luftwaffe bet on jets and revenge weapons, but this only widened the gap between theory and practice. The jets were fast but ineffective in tactical support. The V-bombs had no sight, no decisive impact. The force that was really deciding the fighting, the one that destroyed ships, convoys, supply lines, was made up of conventional planes, modified into hangars and produced by thousands. It was the victory of adaptation over the obsession with the ideal. From a strategic point of view, this meant that Germany had lost not only the present of the war, but the future of doctrine. Their planes were designed for the kind of conflict that no longer existed, their factories to a pace that was no longer viable, his decisions for a time that the war did not allow. In 1945, when interrogated by British forces, the Luftwaffe's chief engineer of air armaments summed up the German dilemma in a brutal sentence: "While we were waiting for the perfect plane, The Americans had already flown 1,000 times with the imperfect. But the Americans were not going to stop at the B-25. The next step wouldn't just be more machine guns. It would be heavy fire. And the 75mm cannon, now mounted in series, would transform the medium bomber into something even more lethal, a steel destroyer. In 1944, U.S. air bases in the Pacific witnessed something unprecedented. Medium bombers flying fighter missions, attack planes replacing naval units, and crews adapting tactics in flight that had not even existed 6 months earlier. The B-25, born as a traditional medium bomber, had transformed into something new and downright lethal. With a solid nose filled with 50 machine guns, variants armed with 75mm cannons, and specific configurations for low-altitude grazing, it left behind the old definition of bomber. It was no longer a passive launch pad which operated under escort. He was a predator, and his behavior in combat forced a complete tactical rewrite. For the first time, the same aircraft fulfilled functions previously separated by air castes: ground attack, anti-aircraft suppression, precision bombing, and naval destruction. European doctrines, formed between the two wars, had rigidly divided the sky. Fighters protected, bombers attacked, torpedo bombers sank. Each role was sacred. The Americans broke this logic. Instead of technical castes, they applied the concept of a versatile platform. The same pilot who strafed columns of trucks one day sank destroyers the next. This gave the operational command unprecedented flexibility, and to the crew, the ability to act with autonomy and creativity. B-25 pilots began operating as tactical leaders of mixed squadrons. Their missions involved identifying targets, engaging with frontal machine guns, marking points of attack, and returning with immediate information, all without relying on central radio. The American air war began to work in real time. Unlike German or Japanese rigid formations, the Americans decentralized combat. And that worked, because the plane had ceased to be just a bomb vector. It had become a multi-role combat unit. On the battlefield, this meant that a single squadron of B-25s could destroy convoys, neutralize airstrips, strafe armored columns, and even return for saturation bombing, all in a single mission. This versatility baffled the Axis intelligence services. Japanese reports pointed out that the same model of aircraft performs multiple functions with minimal variations, suggesting that the U.S. used undetectable aircraft. But it wasn't camouflage. It was adaptation. This technical revolution reflected a deep understanding of modern warfare. That response time and operational versatility were worth more than pure expertise. While Germany invested in aircraft with specific functions, the Americans created machines that did what was necessary, even if they were not born for it. The impact on doctrine was immediate. Manuals from 1942, which still treated the B-25 as a tactical bomber, were replaced by direct attack instructions, low-flying schemes, and evasive maneuvers against anti-aircraft artillery. The Air Force was beginning to train a generation of pilots for a war that no longer had static rules. What's more, the success of the new air doctrine came not only from the planes, but from the philosophy behind them. By allowing technicians like Gunn to modify platforms and pilots like Lana to create new forms of attack, the U.S. has built not just a machine, but a mindset. In Germany, doctrinal rigidity persisted. The Luftwaffe tried to create answers with specialized aircraft, such as the FW-190F, but never achieved the versatility of the B-25. The Germanic tactical culture required a clear function, hierarchical command and action within the plan. In the Pacific, chaos was taken advantage of and defeated. The emergence of this new category of aircraft, the attack bomber, was not in any European playbook of 1939. It did not exist in the minds of theorists, but now, he defined war, a lethal hybrid, a direct product of the American freedom to improvise, adapt, and win. And this new flying monster's next mission would show the world what he was capable of, because soon, a single B-25 armed with a 75mm cannon would face alone a Japanese naval escort, and it would survive. After the Bismarck Sea, the B-25 attack bomber was no longer just a threat to convoys. It has become an instrument of logistical collapse. The next phase of the American air offensive would use the gunships for something even more strategic, nullifying the bases that sustained the Japanese advance. The first of these operations took place at Wewak on the northern coast of New Guinea. It was a vital airbase with dual runways, reinforced hangars, and fuel depots that supplied the entire Japanese front line. In September 1943, a squadron of B-25H armed with 75mm cannons and frontal machine guns launched the attack. Flying just 15 meters above the ground, they crossed the enemy field, strafing planes still parked, destroying hangars and setting fire to kerosene tanks with millimeter precision. Within 7 minutes, 90% of the base was on fire. Allied reports confirmed the destruction of 100 Japanese aircraft, most before they even took off. The American losses? 2 planes damaged, none lost. What had once been the mission of heavy bombers at high altitude was now done by tactical bombers that attacked like fighters and bombed like aerial battleships. The success was so absolute that the mission became a model. In the following weeks, the pattern was repeated in other strategic locations. In Rabaul, a fortified stronghold with concentrated anti-aircraft defense, the B-25s launched precision strikes that rendered runways unusable, destroyed ammunition depots, and cut off the logistical flow of the Japanese Axis in the South Pacific. The key was always the same: speed, low flight, frontal armament. The B-25's strength was not just in the weapons it carried, but in the doctrine that allowed the pilot to decide, maneuver, and destroy in seconds. Meanwhile, Japanese doctrine was crumbling. The Imperial Air Force was built on a logic of territorial defense, fixed bases, protected fields, predictable supply. This required long logistics chains, safe shipping routes, and constant replenishment. But against the gunships, none of these premises held up. If a convoy was detected, it was destroyed. If a base was supplied, it was attacked. And if planes were parked, they were eliminated before takeoff. More than isolated victories, the B-25s were redesigning the theater of operations. Pilots received intelligence in near real time. Missions were adapted in the air. A target that did not exist in the morning could be attacked in the afternoon. This was possible because behind each plane there was a tireless industrial machine. The United States had excess fuel, spare parts on each island, and pilots being trained in record time. The superiority wasn't just air, it was structural. At the end of 1944, the Philippines became the scene of the largest demonstration of this new doctrine. The B-25s led the strikes against Japanese bases on Leyte, Luzon, and Mindoro. In some cases, they carried out up to 4 sorties a day. Entire airfields were destroyed with serial attacks, always coordinated, always with a direct impact on the enemy's vital infrastructure. Japan just couldn't keep up. Without enough oil, without parts, and now without experienced pilots, their bases became traps, static targets in front of a constantly moving air force. While the Japanese generals tried to reposition forces, the Americans were already planning the next jump. Each island conquered became a new base for refueling and extending the range of the B-25s. The American logistics chain functioned as a modular organism, flexible, expandable, and above all, ruthless. The doctrine of warfare in depth, destroying not only the enemy but his ability to fight, was taking concrete form. The irony was brutal. Japan, which had started the war with swift and unexpected attacks, now suffered exactly what it had previously inflicted. Entire bases burned before breakfast, planes disappeared before takeoff. The Japanese military infrastructure, built with millimetric effort over years, was disintegrated in hours by planes that, months before, did not even exist as a tactical concept. And the Allied internal reports recorded the result. In just 3 months, 60 airfields were attacked, 200 planes destroyed on the ground, and more than 800,000 liters of fuel rendered unusable. Japan was bleeding, not for lack of courage, but for lack of mobility. And the next mission would show that not even the ports were safe, because the B-25s would now be used to attack the backbone of the Japanese war effort, coastal arsenals. The war against ships was about to become a war against shipyards. While the B-25s destroyed ports, bases, and ships at an industrial pace, Paul Papygun quietly carried on a particular war. To many, he was the renegade engineer who had rewritten Pacific Air Doctrine. But behind the machine guns there was an absence that no operational success could fill. His wife and children had been missing since the fall of Manila, trapped, perhaps dead, perhaps waiting for a rescue that never came. Every bolt he tightened, every plane he pitched, was an attempt to accelerate the impossible, to defeat a war machine, and in the process, get his own family back. For months, Gunn refused to accept any formal promotion. He slept in the hangar, ate between the engines, and only left when a new plane was ready. His body deteriorated. Repetitive strain injuries, workshop burns, compromised hearing. But he never stopped, because for him, every gunship in the air was a promise, a mission closer to Manila. In mid-1944, war began to approach the Philippines. The islands, occupied since 1942, were now priority targets. American intelligence knew that Japanese prison centers were active in Manila, and Gunn's name began to circulate among commanders, not as an engineer but as a symbol. It was impossible to ignore the fact that their creation, the B-25H, was playing a vital role in the bombing raids opening the routes to the reconquest. It was at this moment that fate and engineering collided. A group of B-25s, armed with 75mm cannons and led by pilots personally trained by Gunn, were given the mission to suppress coastal defenses south of Luzon. The attack was precise, brutal, and effective. On the ground, Allied forces advanced, and days later, American units finally liberated one of the prison camps in the Bilibid region. Among the survivors, Gunn's wife and 2 of his children. The reunion was not cinematic. Gunn arrived days later, exhausted, injured, and almost unrecognizable. But what was seen there was not a celebration. He was a broken man, seeing that his private war was over, and that the price of victory would still accompany him. Medical records showed a severe picture of physical exhaustion and nervous breakdown. He was removed from technical duties and hospitalized for weeks. The irony of this story is that while the world celebrated American engineering as the engine of victory, the man behind one of the war's greatest tactical contributions was just a father trying to save his own home. If you're enjoying unraveling these facts that unite technology and humanity, like and subscribe so we can continue to reveal stories like this, where numbers gain soul. And although Gunn left the hangars, his creations didn't stop, backwards. The next stage would take the B-25s into new territory, the skies of occupied Indochina, where German doctrine would be put to the test again, and would be, once again, surpassed by impossible ideas. In 1945, when the last echoes of the war still reverberated among the rubble of the Pacific, the doctrine that had been born clandestinely in Paul Gunn's improvised hangars began to officially spread through the world's centers of military study. The cannon bomber, once an illegal experiment, was now the subject of technical analysis in reports from the RAF, the Soviet Air Force, and even the French General Staff. In the British archives, a confidential document from 1946 detailed the effectiveness of jump attacks and suggested the creation of a fleet of tactical bombers with fixed frontal armament for missions in colonial theaters. The Soviet Union, in turn, began the development of its own multi-role aircraft, noting flexibility as a weapon. For the French, the campaign in Indochina revealed that American doctrine was more than effective. It was necessary, but it was within the American ranks themselves that Gunn's legacy took its most lethal form. In the Korean War, when the need for air support in mountainous regions required saturation fire at fixed points, the AC-47 Spooky appeared, a cargo plane adapted with side machine guns. It would not exist without the concept of the bomber cannon. The same was repeated in Vietnam, where the AC-119, and later the dreaded AC-130 Spectre, carried 20mm, 40mm, and even 105mm guns, capable of maintaining a continuous circle of destruction over enemy positions. Each of them carried in their tactical DNA the solitary decision of an engineer in New Guinea. These aircraft didn't just repeat the concept, they expanded their scale. Gunn's improvisation had become science. Air tactics manuals now included standardized procedures for frontal attack, low flying, anti-aircraft penetration, and jump bombing. Adaptation, which had been a reason for punishment, was now doctrine, and with it came a new way of thinking about war, decentralized, responsive, and above all, practical. While the Germans were still documenting ideal designs, the Americans were teaching in military academies that the battlefield defines the weapon, not the other way around. This created an entire generation of officers prepared to modify, adapt, and lead with freedom. The impact was direct in the coming decades of asymmetric conflicts, where flexibility became a tactical and strategic weapon. The most symbolic was the adoption of the concept of gunship as an official category within the USAF, a nomenclature that, in itself, was an unintentional tribute to the mind of Paul Gunn, Airplanes originally designed for transport were now armed as flying fortresses. Missions that once required entire battalions could be accomplished by a single aircraft, orbiting, deciding, and eliminating. And it all started with an unpatented technician who did not ask permission, but historical recognition was still lacking. In 1967, during an Air Force tactical evaluation ceremony, one of the manuals presented cited, for the first time officially, the term gun modification lineage, the lineage of gun modifications. It was more than a name. It was the institutional acceptance that modern warfare had been, at least in part, won by productive insubordination. And the echoes of this revolution still reverberated, because years later, a commission of West German military historians would visit the United States to study the doctrinal errors of the Luftwaffe. One of its members would write in a bitter tone, "We underestimate not only American industry, but its culture of war. While we were trying to achieve perfection, they were already winning with the imperfect that worked." And it was precisely this functional imperfection that, in the next part, would face the last test, a suicide mission that seemed impossible, until the bomber cannon decided otherwise. During World War II, the failure of the Axis powers lay not in isolated technology or individual talent, but in a fundamental error of strategic design, the inability to adapt to the dynamic warfare that the Allies, especially the United States, imposed with industrial speed and tactical creativity. Germany and Japan, each in their own way, maintained a rigid chain of command, an almost religious attachment to time-honored doctrines, and an obsession with perfection that prevented them from reacting nimbly to the new realities of combat. Japan relied on its naval escorts, battleships, and destroyers to protect supply lines that had become vulnerable to American ground aviation. The belief that fast, well-armed ships were untouchable demonstrated a critical underestimation of enemy adaptability. In contrast, the United States did not expect every modification to be approved by endless committees. Experimented, tested, and produced. Paul Gunn's modified B-25 bomber arose not from manuals or meticulous plans, but from the improvisation and urgency of an engineer who had his own family as motivation and an entire theater of war to protect. Each plane that left American hangars was not just an attack platform, but an extension of the flexible mindset that defined American industrial superiority. Germany and Japan faced an advantage that could not be measured only in the number of aircraft or ships but in speed of adaptation. American production was modular and responsive. Factories could incorporate field-tested ideas almost immediately, while the Luftwaffe insisted on approval cycles and laboratory tests, and the Imperial Japanese Navy clung to rotations and escorts defined by decades of tradition. Each day lost represented a strategic and operational loss. Internal Luftwaffe reports showed growing frustration. Engineers proposed adaptations that were immediately blocked by bureaucracy. The direct consequence was clear. The Axis could not generate quick solutions when its supply lines were threatened by American cannon bombers that could attack ports, airfields, and convoys with an unparalleled combination of weapons and tactics. Each low-altitude B-25 mission demonstrated the failure of a rigid doctrine in the face of dynamic warfare, forcing Japanese officials to admit in confidence that the Americans don't just attack, they reinvent the attack as they fly. The morale of the Axis forces dropped as it became apparent that there was not enough responsiveness, neither to keep their ships safe, nor to preserve air bases, nor to protect fuel depots that sustained the war throughout the Pacific. German production, even with its technical efficiency, was fragmented among rival ministries and depended on centralized approvals. Meanwhile, the United States transformed improvisation into a standard of production, tactical innovation into doctrine, and individual adaptation into national industrial capacity. Each modification applied to the hangars in Australia or New Guinea was quickly replicated and incorporated into new batches of B-25s, multiplying effectiveness without overloading the chain of command. This created a continuous cycle of operational advantage that no Axis power could match. The historical diagnosis is unequivocal. Without flexibility, without the ability to quickly absorb external innovations, without decentralization and tolerance for error, any technological power, no matter how advanced, is condemned to obsolescence in total war. American industrial power, coupled with the operational freedom granted to pilots and engineers, not only produced aircraft, but invented a new form of warfare, redefining what was possible in air and naval combat. The conclusion is clear and morally instructive. The strategic rigidity of the Axis powers, the belief in perfection, the bureaucratic centralization, the contempt for experimentation, not only limited their ability to react, but sealed their fate. And the lesson applies not only to historians, but to any observer of industrial and technological forces. Innovation without freedom is unrealized potential. Discipline without adaptation is an inevitable weakness. The next chapter of this narrative will reveal how, as the war progressed, every element of Gunn's improvisation and his production line of B-25s became critical to the final outcome in the Pacific, showing that American supremacy was the result of a combination of ingenuity, institutional freedom, and industrial power that the Axis could never replicate, regardless of their naval technology or tradition. The message that emerged from the American arsenal during World War II was not only made of steel, gunpowder, and aluminum, it was imprinted in the culture that allowed men like Paul Gunn to exist and, above all, to create. While Axis powers relied on dogmas of technical purity, rigid chains of command, and an almost liturgical faith in the perfection of their equipment, the United States discovered that modern warfare belonged to those who dared to improvise, make mistakes, adapt, and try again. Before the enemy had time to breathe, the gun bomber, born of repurposed parts and personal pain, became a symbol of this mentality, a brutal hybrid that rejected theoretical elegance in favor of immediate effectiveness. Every 50 mounted, every support welded without authorization, every test run at night in makeshift hangars represented the difference between a war guided by manuals and a war guided by moral necessity. The Japanese soldier saw only the blast that destroyed his ship. The German officer saw only the final result in the strategic reports. But the real meaning was in the process, an entire nation accepting that the perfect solution is not the one that shines on paper, but the one that works on the battlefield. And for Americans, functioning meant taking risks. Industrial power, which transformed a workaround into a national production program, did not exist in isolation. He depended on institutional courage to say yes to ideas that would never be approved in Berlin or Tokyo. It was a culture that understood that technology is human, flawed, evolutionary, and for this very reason capable of overcoming adversaries who kneel before their own technical pride. Paul Gunn didn't just modify a bomber. He proved that in the face of the impossible, rigidity is strategic suicide. His story reveals that the morale of the battlefield lies not only in the destruction caused, but in the freedom that allowed him to cause that destruction. This is the silent theorem of war. Creativity wins dogma, adaptation beats tradition, courage beats perfection, a lesson that German historians would recognize decades later, admitting that they underestimated the very thing they could not measure, America's ability to turn despair into innovation. And it is this same ability that, in the next part, will reveal the moral and strategic conclusion of this entire saga, how an unknown engineer redefined the future of warfare, and why his legacy echoes to this day in every gunboat that crosses the sky. At the end of this long journey, it becomes impossible to ignore the central fact that guided every scene of this story. The ideological and operational collapse of the Axis powers did not occur only on the battlefield, but in the very belief that underpinned their war machines. Germany, with its faith in technical perfection, and Japan, with its quasi-ritual devotion to naval supremacy, were defeated by something that did not fit in their playbooks: the American ability to turn improvisation into doctrine, pain into engineering, and necessity into mass production. When the first modified B-25 took off from the red land of New Guinea, carrying 8 50s assembled without authorization, an era was quietly ending. The era in which it was rigidly believed that ships dominated the seas, that bombers should fly en bloc, and that wars would be won by the ideal weapon, not the possible weapon. Paul Gunn's trajectory, marked by loss, urgency, and a creativity that surpassed any regulatory limit, synthesizes this historic turnaround. He won not because of the rank he never had, but because of the freedom his nation granted to those who dared to solve problems before they were approved. And therein lies the universal lesson of this narrative. In wars, and in economies, victory belongs not to the most precise but to the most adaptable. It is flexibility that underpins the strategy. It is logistics that sustains strength, and it's the ability to experiment, fail, correct, and scale that sustains victory. Decades later, when German historians analyzed Allied production and modification data, a former Luftwaffe officer, interviewed anonymously, summed up his defeat with brutal candor. "We lost to a factory that thought faster than our entire general staff." The phrase contains the irony that permeates this whole story. Gun's forbidden weapon, born without permission, has become a symbol of an uncomfortable truth for the Axis. Modern warfare does not reward dogma, it rewards adaptation. If you believe that stories like this, made of facts, figures, and hidden truths, deserve to be preserved, leave your like, subscribe, and support the research that keeps this channel alive. Comment on the most shocking data for you, and ring the bell so you don't miss the next devastating historical fact that we are going to reveal. Don't go away yet. Listen to the next real story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another amazing story.